Welcome back to Shop Talk with Mike Festiva. In this episode, we got a lot of interesting topics to talk about. First one is going to be paying it forward and things I've done to help friends around me and things that you might be able to consider to help other people out as well. Next, we're going to actually talk about a repair at my work that was kind of a complex repair because, well, we'll go into the fact that when engineers and companies don't actually work with the people actually building the products, how that can really lead to problems later on for customers and maintenance. We'll go into that. It'll be interesting. Got some videos, some repairs at my work on a CNC machine. After that, we're going to go into how I got started on YouTube. I didn't actually plan to ever actually have a YouTube channel. It just kind of came to be. So we'll talk about that. And last, we'll cover how to actually take on bigger projects without being overwhelmed. So stick around and enjoy the video. Before we get started on Shop Talk, I actually want to thank all my loyal subscribers for checking this video out. I have about 15,000, maybe 20,000 core subscribers that really are interested in more than just strictly entertainment. And that's kind of why I want to actually make this series, is just because I find it's a fine balance between entertainment and adding tips and fabrication stuff that you guys can learn from on my main build videos, because a lot of my subscribers seem to just want to see entertainment, not all of them. But if I start adding a lot of tips in the videos and talk more, I get some rude comments like, shut up, you talk too much, and, things like that are rude. And I just block those people. I've had it with that. But really, I can see like how the view duration on those videos, and if I actually talk a lot about shared tips, the view duration in the final build video is a lot shorter than if it's just strictly entertainment. So I'm making Shop Talk just share more ideas and projects and things I want to share with you guys and girls about welding and taking on projects and just different things that are interesting. So thank you so much for checking out this series. So first off, I really want to talk about paying it forward and how I have paid it forward to friends and people I know, and how you can maybe do the same. And I think it can help a lot of people out, and you don't always have to make a profit off of things. You just pass stuff on and help people out. So I got a Langmuir welding table right here. Some of you have asked about it. Unfortunately, I don't have a promo code that will actually save you any money on that. I'm sorry, I wish I did. This is from the same guys that make the CNC table, and I bought two of these tabletops about 6-7 months ago. Never had a welding table this nice, and I've actually had some people ask, like, should they start off with one of these when they first start learning how to weld? Honestly, it costs quite a bit of money to get into a welding table like this. If you're just starting off welding, you can work with, like, Harbor Freight makes a tiny little welding table, or just put a sheet of metal on top of a little work table and start with that, But basically, I've been welding for quite a few years now, and I finally want to get one of these fitment tables here. About 4 years ago, I think 3 years ago, I built this little plasma chop saw kind of a tool that sat here, and most of my videos were around. A lot of projects were built on that. It was graded over here with like salvage material, catwalk, and I made this basically plasma arm. I'll put a little side view of some of the videos of building that thing, and there's a link to that video. But I made this little chop saw plasma table area with a motor drive on it and a little tiny welding table, and I worked with that for a long time. But after I got this, and I have the CNC now, it was really just taking up room, and I felt like I wasn't utilizing it much anymore, and I wanted to pass it on to a friend because I got this table here. I needed room in the shop. So I called up my friend Norm, and I know he's starting to get into fabrication a little bit more, and his son's at the age now about 9, and he's interested in doing a little more work and projects around the house with his dad. So I gave my friend Norm that little plasma track that I built, and along with the plasma torch I had. It was like a Cut 50 Amazon plasma torch, and he was super happy about that. He's already used it on a bunch of projects around his house, and I made room for this table. And it was just one of those things that's really nice to pass that kind of stuff on. Another tool I passed on to another friend was the Amico CTS. I don't know what size, 160 or something like that. I've done a review on that in the past. Because I have a lot of TIG machines, I had a lot of people asking about plasma cutters around that time and what I would recommend for a cheap plasma. So I tried that machine out, made a review video, used it a bit, and really I didn't need another machine. I mainly did it because people were asking about affordable plasma machines, and that one seemed interesting because it was a high frequency TIG and stick welder combo. And that machine I didn't need anymore, so I gave that to my friend Walter because he's never TIG welded, and he's been using the oxygen acetylene torch to cut metal at his house. He's a long-time fabricator, but he's kind of working old school with that. And I was like, man, you should just use this thing for a while. Loaned it to him for like 6 months. He used it, loved the plasma, and he was like, I can bring it back to you. I was like, man, just keep it. I would rather you have it. I got another plasma on the CNC table. So the whole idea with this is paying it forward. You know, I've gotten better tools and I've passed on the older stuff. So like if you have a welder, an extra welder in your shop, you have a nicer machine and this one welder is sitting in the back corner, taking up space, collecting dust, consider passing that on to a friend or somebody you know that's kind of interested in learning how to weld. Maybe even sit down and give him or her a little bit of a tutorial on how to weld and how to weld safely and be smart about it. And pass that knowledge on and pass that machine on. And me and my friends, we don't have to like say, hey, don't sell that and make a profit on it. It's kind of an unspoken thing we don't even have to share with each other, that you don't get something for free and sell it and make a profit on it. But if you're passing on somebody and you think they might do something like that, just say, hey, listen, be respectful. I'm giving this tool to you. I could sell it because it has some value, but it has more value to me to pass it on and share this information with you and give you a free tool. Just don't make a profit on it, please. So that's a little tip on paying it forward. And if you can help someone out around in your neighborhood or something like that, or a friend, please do so. Before we're done with this welding table topic, I actually want to talk about a few little things I've made for it, and I'm actually going to include making more of these things and share them with you when I actually develop more. But these holes all across here are 5/8. Pretty simple. So you can just go to the hardware store and pick up some 5/8 bolts. These are of course way longer than they need to be. I just had them in my toolbox around here. So you can drop those in. You can square stuff up on there. Another thing I did if you have a lathe is I got some, I think it might be 1/2" hardware, and I cut it down, nut and then the top of a bolt. And basically there's slight adjustable mini like precision jack stands, so you can put a part on here if you want to bring it up a few degrees and you're welding something, you can raise them up or lower them down. It was just kind of brainstorming different ideas. These are awesome little clamps. I use these all the time. You can get them at Harbor Freight for like $2.50, $3. And the original clamps for these tables, they vary from like $20 to $50, like outrageously expensive, especially if you want to hold down with a lot of clamps. Like you don't want to spend hundreds of dollars on them. So you buy a $2.50 clamp. I shared this like 4 months ago in one of my videos. You buy some 5/8" rod. You can get it on like nice rod on eBay. You can get like for $20, you probably get 5 1-foot sticks. So you got plenty. And basically you just cut off the end of this clamp here, weld this 5/8" rod to it. It drops in, and then you can bring it down and lock your components down. Since after sharing that video, somebody else on another welding channel shared it as if it was their own idea, which is fine. It's at least they're passing on the knowledge. But it's kind of one of those things, like it came out after I made my video, and even just a little bit of credit, like, oh, thanks for Mike for sharing this with us, but whatever, it is what it is. But I want to share this stuff with you guys. Oh, one other thing I want to make is these are like $15 little hold down like drill vices at Harbor Freight. And one other thing I want to build is a simple pin system so I can drop the vise in here and lock it onto the table. So it actually, I can have a quick change vise for holding bits and pieces. And I'm going to come around over the side here and point out one other thing I made, which is kind of handy for welding on a welding table a lot. So here's a handy little thing I built a while back for this as well. I had this on my old welding cart too I built. But basically, I took some 5/8" rod, drilled the end of it and tapped it so it can go into one of these holes. You can mount this anywhere on your table. And this right here is actually, we had some broken bottle jacks at my work, and this is where you put the handle in to raise up and down the bottle jack. You could basically use any type of tubing that fits your MIG gun in. And you can put your TIG torch on there or your MIG gun, and it's super handy. You can be welding something, instead of setting it here and having it fall off, you can just slide it here like a holster. Works pretty well. And of course it's a 5/8" rod, so you can mount it anywhere around your table. Get it adjusted how you like. Pretty simple. All right, so this story I want to share with you is basically something I was working on at my work the other day. I have a day job. YouTube is just kind of a side project and a job for me. But basically, I do millwright work, and I work on a lot of CNC equipment. I don't program them, I don't operate them, I actually just strictly maintain them. When something breaks, I fix it. Basically, we had a large, I think it's a 5 or 6 foot wide table, wood router by maybe 12 to 14 foot long, one of many machines. And this has a gantry that goes up and down on the table, and it has 4 wood routers that are all chained together and basically in sync with each other. And the gantry moves up and down. There's a large ball screw on the bottom of it, and it goes from end of table to end of table, and the whole gantry gets pulled up and down. And off of the stepper motor, it comes up over with the little cog timing belt, like a little smaller than a timing belt on a car, about a loop about that big for the belt. We had some more belts on order because that was actually starting to fray and is losing a few teeth. And if that actually jumps timing, the products you're trying to cut and precisionally will not be precision anymore, it'll jump timing. So what happened was that cog belt finally broke, and we had our other belts right there. So tear into the machine, looking it over, and that ball screw went from end to end underneath the table. There were some clamps on there. I thought, that looks pretty tight. But most of these machines you don't have manuals with. You just get in there and figure out how to repair them and tear into them. Some jobs are easier, some jobs are more difficult, but this one looks simple. It's a rubber belt. You just plan on it being something the company designs into the machine to be easily replaced. If it's a rubber belt, it's going to break at some point. So we loosen these clamps on there to get some room. We figured all we need is a cog belt's very thin. We need a 1/4 inch of room from end of table underneath to move this ball screw so you can get this belt around it so you can get the machine up and going. Keep in mind, this is a full production machine. We're running it 10 to 12 hours a day, 4 to 5 days a week. You can't have it down very long. You know, the repair looked like it was going to take an hour to an hour and a half if everything went smooth. And we're tearing into the machine. Like I said, there's no manuals for this stuff. We just kind of figure it out as we go. Looked pretty straightforward. We got in there and realized there was no room between this ball screw and the end of the tables. It looked to us as if they basically dropped the stuff in from the top with that belt on there and planned it to be that. And it's just not right. It's like, who would engineer a machine that way? We rarely ever call a manufacturer and talk with their customer support about this stuff, but we called them up and we got talking to the guy in customer support, and we said, hey, you know, we're trying to change the belt for the gantry, and it appears there's no room for this to get this belt around this machine. He said, well, we designed that belt. It should last the life of the machine. Oh, well, it's a rubber belt. You never consider your alternator belt lasting the life of a car or truck. It's like, you got to be kidding me. And no, they should last the life of a machine. It's like, no, this is about 4 or 5 years it's been on the machine, but you should get a lot more than that out of a $50,000, $60,000 machine. And he said, no, they usually last the life of a machine. I was like, so you guys didn't build this into the machine, how to service this? No, it should last the life of a machine. We kind of chuckled, you got to be kidding us. And no, that's kind of how it is. So I was like, well, how do you expect to change it? Well, I would assume you'd probably have to pull the top off of the table, which what he referred to would be a day and a half or 2 days worth of work, buttoning it up and getting it all finished. The problem with that, on top of this table, it's got a vacuum hold down to hold all the material down so it doesn't shift while it's routing. Basically, what you would end up doing, what he was suggesting, was we have a layer of plywood on top of the table. It came from the factory this way with channels cut in it and a whole bunch of vacuum tubes, PVC tubes coming out of it for a network of vacuum hold downs. All that would have to be pulled off, plus a spoiler board that gets re-glued down. It's kind of expendable wood top on it. And basically that gets cut down every so often and to recalibrate the table, make sure it's flat. The guy suggests we remove all that table. The problem is, to get to the hardware that's holding down the lower part of the vacuum, you have to mow what we call mow the deck. Basically, you put on cutting blades that are bigger on all 4 heads, and they go back and forth and remove the rest of the material till you get down that lower sub vacuum hold down. All the hardware was covered up, and you couldn't run the gantry up and down because the belt was broken. So he asked, can I help you with anything else? Like, at this point, no, appreciate it, but we're going to figure out our own way. We're not spending a day and a half to 2 days to pull this machine apart. We got better ideas. And that just really goes to show how poor the engineering is in this company. Who would ever put a belt on a machine and expect to send out the door? The guys building it should have said, hey, engineers, this is a really bad design, because the guy that goes to repair this is not going to have an easy way to repair it. You need a feedback loop when it comes between engineering departments and manufacturing, because it can really affect the customer down the road. And we'll get into a little bit more of that at the very end of this topic. Back to the repair. So basically, we got off the phone with the service guy, and we went back to the router. We grabbed a electromagnetic drill that we had, put a nice hole saw on there. I think the ball thread screw was like 2 inch or 2 1/4 inch diameter, so we got like a 2 1/2 inch hole saw. Put the electromagnetic drill on the end, drilled through the end plate that's 1/2 inch thick, so we could slide that ball screw out about 1/2 inch, and then put not one belt to repair it, but we put 3 belts around it, saving it for whether I'm still at that place working 5 years from now when it breaks, or somebody else is. It's going to save them a lot of work. We put one belt on the machine so it can get up and running again. We put two more belts that were taped and zip tied under the machine out of the way of the gantry. So when that one belt breaks, you just bring one more over. That manufacturer should have done that too. They should never expect one rubber belt to last the life of a machine. Bad engineering. So get back to feedback loops and engineering. When I build stuff here, I kind of think of it, how would I build something so I can easily maintain it? Sometimes you get stuck in a corner. You can't always do that. Some things are going to be more complex, but I think back on all the jobs I've done on heavy equipment and cars and trucks, and sometimes you see really good thought out engineering. You see some really bad engineering like we came across the other day. Speaking of that, we actually, after we cut that hole in the side of that machine to get that ball screw moved out of the way, I think once we got the hole cut, we got the machine finished and up and running within an hour and a half, not a day and a half's worth of work from the company's suggestion. Basically, if an engineering department's going to design a machine, they need to be working with the fabricators too, building it, because if they don't, a flaw in a machine from engineering or fabrication can actually keep cascading onto model after model or years worth of a run. And that's really a bad way to develop a better machine or equipment. You need a feedback loop between the departments so they're all working together. Some of the engineers at my work, they actually will ask me to come up and look at their drawings and some of their stuff if they're working on some special racking or some type of machine and want me to look it over. They actually really enjoy my input on it because basically I'll look it over and say, that's good, looks great on screen, that makes sense, but right here is going to be an issue for fabricating. And I'll explain why, and I say, if you do it this way or this way, it's going to be a lot easier for me or somebody else that's going to be building this product. Assembly-wise will make more sense. They're always happy to make changes, and they're always happy to hear my input. So by working with the departments, manufacturing or fabrication with engineers are key to making a successful company and successful products. All right, I hope you enjoyed that little story. So I'm going to share with you shortly just how I got started on YouTube. Going back about 6 years, I never planned to have a YouTube channel. I kind of built all my projects out of necessity, like the quad truck on my shirt here. I needed a way to haul firewood. I had a broken down quad. I repowered it, put a truck bed on it, made it function for me on a complete budget. That was like 4 years ago. Going back further, like 6 years ago when I first uploaded my first video, I built a sawmill. I had property, I had some logs, mills were wicked expensive. At the time, there was no way I could afford a $4,000 or $5,000 mill. So I started looking into on YouTube, trying to figure out how to design one. Looked at a bunch of homemade mills. I saw some that worked poorly. I saw some that worked good. Got some cool ideas from that. I also looked at commercial built mills on YouTube. And I felt like I did not want to be in the first video, or didn't even want to have a YouTube channel, like I said. I just wanted to build a video with documenting it, shooting shots along the way. I didn't talk in it, do any narration, just put text on it. Didn't want to be in it. I just want to share, like it was about a 14-minute video. I'll put a link over here of just how I built the mill for about $250 by repurposing other parts and pieces that most people can find. And it cuts pretty dang good. Basically, I just wanted to post that one video and be done. I didn't even know how to do it. My neighbor at the time was doing little bits of videos. I'll put his channel link over here. I'll put it down below in the description. And he was doing these rocket stoves, and I got into building those too, but I never posted anything on the channel. He showed me kind of how to actually post a video on YouTube. I had no clue. I actually had to go down to his house, use his internet, because my internet was too bad to get the video uploaded. Still is too bad to do that at home. I made this 14-minute video of how I did it. I just made the video mainly to give back to the YouTube community. I had no real interest in actually making more videos, but one thing led to another. People would ask questions about the mill. I'd try to get back and reply to them. People want to see the mill running some more, so I'd post a video every 4 or 6 months or so. On occasion, really didn't have any interest in growing the channel, but it was cool getting comments from different people, seeing the subscriber grow. I was like, oh, that's interesting. Want to share more projects with everyone. Even up to about a few years ago, I kind of wondered, like, I don't know what I'm going to do with this YouTube channel. Should I just like stop posting and let it fade out? Should I post more? I'm not really sure. How do you end it if you're done? And I decided, instead of ending it, I'm just going to see if I can progress with the channel more, grow it. And so about 2 or 2.5 years ago, I decided instead of doing a video every 4 months or 6 months, I'm going to post a video every other Friday. So 2 videos a month. And I've been on that schedule. I haven't broke that schedule. I've done more than 2 videos a month, but I've never done less than 2 videos. It's been about 2.5 years. And it started out as just kind of a little hobby, and then it's turned into a side job. Literally, like, it's a ton of work. It takes so much work to film these projects, ordering parts, figuring out how to engineer it, videoing it, trying to get microphones so it actually picks up what I'm saying, trying to get better at editing. I can't upload the videos from my house. My internet is still poor 6 years later, so I have to upload that at work. And just even putting all the description in the videos, all that stuff takes a lot of time. But I still have fun doing it. Some moments I feel like it's a ton of work, and I kind of wonder if I still want to continue on doing this. But in the grand scheme of things, I still enjoy it. And one of the things I really like is reading the comments. It's harder and harder to keep up on reading the comments, because post a new video, I'll get like 400 or 500 comments on that weekend. But I try to get back to everybody that I can. One thing I want to mention about comments, most of you know I live in the Northwest. I'm up in Washington State. Once in a while, you guys will mention, like, I'm from Scotland, or if I'm from Australia, or I'm from Quebec, things like that. You know, if you leave a comment on this video, just leave a simple thing. You don't have to leave your address or anything like that. Not that descriptive, but like, just mention the country you live in, or province, or state, something simple like that. Because I see a lot of people and their little thumbnails and their names. I read a lot of the comments and notice certain people that always reach out and comment on my new videos. But I kind of wonder where you live. You know, you live in the Midwest, you live in Washington, do you live, you know, Alberta? Where do you live? So if you leave a comment down below, just put it in the very end, like, I'm from Ireland or something like that, or from Japan or wherever. Just be interesting to hear about that. So we're getting closer to the end of the video. I know it's been kind of long, but I had a lot of things to talk about. This one, I actually want to talk about touching base on breaking down a bigger complex project. Say if you're just starting out with fabrication, or you've been doing it for a while, but you're not quite sure about something you wanted to do, but it seems too daunting and you're not really sure how to start it. What I like to do on bigger projects, because I had to do this on the mill, for instance, that was one of the more complex things I built up to that date. And it's so easy to get overwhelmed on big projects that it's so easy to not start. You know, where I'm going to start, you get frustrated or overwhelmed. It's so easy, like, maybe I'm not going to do that. You should do it. You should stick with your goal. Keep working at it, even if it takes months. But what you should really do is break it down to simpler forms. Don't look at something like the sawmill, for instance, of a whole giant machine you got to build. Break it into components. You know, think about the track, how that's going to go. Think about that and maybe work on that for a while. You can consider how it's going to affect other components down the road, but you can break things up like the blade guides. Break that up to a component, and that blade guide fits on bigger part of the gantry and how that's going to fit. But you can take all those things like the motor and drive and break those into a complex part. You don't necessarily have to focus on the whole mill. You do have to sometimes consider how that part will fit to another component, but you can do that. But by thinking about things that way and breaking it down to smaller components, you can actually break them into smaller pieces that you can actually process and handle. And then what you can also do is you see that your project is progressing and you build confidence in the project. Because if you can build that component and see how it's going to fit to another one, you start seeing the bigger picture, but without being overwhelmed. And you get encouragement by seeing some of those smaller components that are finished. And in that mindset, that component is finished, and you can move on to something else. Before you know it, within a certain amount of months, you may have something like a mill or a quad project or something finished. So that was one way that it really helps me to break a larger project down into simpler forms, just not to get overwhelmed, and it can make it easier to like perform the whole project. Another thing I want to mention is when you're designing something that might be complex, a part or something, and you're trying to figure out the best way to do it, sometimes you got to pick a good idea and just like, I'm going to run with it. There's probably better ideas, but I want to get this done and move on. Sometimes you want to put more thought into how that part will relate with another part for adjustment or something. And one thing that is useful is to take a pad of paper, get some basic measurements of the part, draw it out on a piece of paper. And that's your best idea you have up to that point. That's great. You can go with it. But draw it in a way like, how would I actually build this part if it's a multi-part piece out of different parts of metal? Think about that part, and then when you come down to how you're going to actually build it when you're working on paper still. Because sometimes when you start breaking that part down, how you're going to build it on paper, you're like, wait a minute, that is going to be hard to finish off that way. I should drill these parts first on the drill press and then weld them together, because I can do them a lot easier when it's clamped on a flat surface and when it becomes this three-dimensional piece. Sometimes when you break a part down like that, you actually find other ways to simplify it more. When you think about the design work when you're manufacturing, this kind of goes all back into play with engineering and manufacturing. You need to work together. When you're working in your shop, you are the engineer, you are the manufacturer. So when you take those parts and you break them down, you have your first part you design, and then you start design that part and think about on paper how you're going to build it. Sometimes it really leads to the final part being simple and easier to build, and you're going to be able to get it finished a lot quicker that way and have something better that works better for you. And sometimes when you take the complexity out of something and refine it to a simpler form, sometimes that's the beauty in it. Instead of having something complicated and overly built for a simple part, build it to the specs it needs to be. Try to break it down in a way it's more simplified, because in the end it's going to be easier to build, it's going to work longer, it's going to be less complex, and usually simplicity is beautiful. So I know this video is kind of long, but there's a lot of complex topics I want to cover with all of you. The final note I want to end this video on is encouragement. Encouragement for all of you watching it, and encouragement of you passing on knowledge to others. It kind of goes hand in hand with that first thing about passing on an old welder or tool that you have an extra of, but it doesn't even have to be a tool, it can be knowledge. If you have someone in the area that you know, a friend of yours, or a kid that lives in the area that wants to get a welder and weld a go-kart, give them a few tips, pass on that knowledge. You don't have to keep it locked up. There's too many times where people want to keep certain things to themselves because it took a while to learn that. Well, make it easier on someone else. So what if you went to school for 2 years to learn how to do that thing? Help someone out in your neighborhood, help a friend out. And it's just one of those things, pass on the knowledge. We don't have to keep it locked up to ourselves and take it to the grave, because unfortunately we all go that way at some day. But if you can share some knowledge with people and pass it on for what you know, and don't discourage them, encourage them. All right, until next time, take care. Bye.